So arithmetic mean, which I said the mean means what? Average. Now, are we talking about a sample or are we talking about population? If we're talking about a sample, we use X bar to represent the mean. Population, we use mu. This is for population. And this one for a sample. And earlier we were talking about the mean. How would you find the mean? We said we add all the scores and we divide by the number of scores. You add all the scores and you divide by the number of values, number of data, small n. And small n means sample size. This one is the same thing. We add all the values, we divide by the number of values. We use capital N. Small n again, that means sample size, if it's a sample. And capital N means population size. So the way we calculate the mean is really the same thing for both of them. And a lot of people don't call it the mean, they call it the average. It's the same thing. We all know this sigma means summation. Add all the values, especially if you took Excel, auto sum, when you want to add some numbers, you click on that sigma. It means add them, sum them. So the sum of all the values divided by the number of values. Now let's talk about, well, let's take an example first. Let's say we have these values. I was wondering how the first quiz result is, and I took 10 scores from a class of 18 students. So I took 10 scores from a class of 18 students, and these are the scores: 78, 82, 75, 85, 90, 80, 70, let's see, good, 80 again, 70, how many scores do we have? I need one more. Another 80. These are the 10 scores. Let's calculate the mean. Is the mean going to be X bar or mu here? X bar. Why X bar? It's a sample. 10 out of 18. Not everyone. So we add all the values, we divide by the number of values. We add them all. 80 plus 78 plus 82 plus 75 plus 85, 90, 80, 70, 80, and 70. And we divide them by the number of values, which is 10. If I did it right, it should be 800 divided by 10, which is what? The average or the mean is 80. Now let's take my circuit class. Circuit class, I only have 5 students in it. So these are the first quiz result for my circuit class. 50, 60, 90, 70, 80. There's only 5 students in the class. I took the score of each student, wrote them down. I'm going to calculate the average. Is that X bar or mu? Mu. Why? Because we're doing every student. I have 5 people, 200, 350. 350 divided by 5, the average is 70. The nice thing about the mean is we use every single score. We don't skip any of them. A lot of times when we ask people, what about if somebody doesn't take a test or somebody gets a 0? Do you count that in the average? Sure you do. The disadvantage to that, to the mean, the disadvantage is what? What's the biggest problem with calculating the mean? Is what? Absolutely. Yep, exactly correct. So the disadvantage it is value sensitive, data sensitive. What does that mean? If one number is crazy, an outlier, it's going to affect my result. If by mistake I go to enter the score for this person of 50, and by mistake I hit 500, when I tell Excel to calculate the average, guess what the average is going to be? Everyone's going to get at least 20 more points added to their score. Actually, way more than 20 points. I'm adding here another, what, 450? So what's that number? Be 800 divided by 5. Everyone has an average of 160. So it is data sensitive, value sensitive. One bad result, one good result will affect that. That's why I said you can't really judge how well you do in the class by looking at the average. Because if one person gets 100 and the rest gets 30s and 40s, it shifts the grade up there. It looks like you're doing horrible in the class.
It's probably not the most important thing, but it's bothering me. That all adds up to 790, not 800.
Which one? This one?
The first set of data that you put out
Here?
adds up to 790, not 800.
I see 800 there. If it is 790, the average is what, 79?
It is.
Yep. You added them on the calculator?
By hand on my calculator.
Okay. Just want to make sure. So if it's 70, oh, the average is now 79. I was trying to give you an extra point for effort for making it this morning with the snow we got there.
Yeah, traffic was ridiculous.
We made it. That's the good side. So that's that disadvantage to actually just looking at the mean alone. If we just take a peek at the mean alone, that's the disadvantage to it. So now, let's look at the median. When you put the two of them together, actually, when you start to see where the values are, the median is actually the middle value. The value in the middle. But before I say the value in the middle, you need to do one more thing before you look at the middle value, is you need to take your data and what?
Organize it.
Arrange in order. Arrange data in order, organize it. I don't care if you go from small to large or large to small, but you have to put them in order. The symbol that we use for the median is X with the squiggly line over it. It's called X tilde. So X tilde, that's how we pronounce that one. When you see that, that means find the median. I'll show you in a few minutes how to find it, but the nice thing about the median, it is not affected by extreme value. Not. So when you have a number that's really big, it doesn't affect that. Now let's see how we find the median. Let's take a set of numbers. 50, 70, 90, 40, 30, 82, and 76. And I said, let's find the median, x tilde. First thing, arrange in order. Put them in order. Small to large, large, small, doesn't matter. What do we have? 30, 40, 50, 70, 76, 82, 90. And where's the middle value? The number that's smack in the middle. Isn't that this one? How many values to the left of it? 3, and how many to the right of it? That's my median. I know what you're thinking. What about if you have even numbers? We'll come back to it. So when you have an odd number of values, if you have an odd number, the median is what? Is the number located in the middle. In the exact middle. There'll be one exact in the middle there of the list. So when you have an odd number of data, that number will be exactly located in the middle there. And what happens if you have an even values? Not odd, even.
Pick the median value that's closest to the mean.
Well, let's see. Wait till everyone's done writing. Everyone's good? Okay. Well, I'll put that. When you have an even number of values, the median is found by computing the mean of the two middle values, middle numbers. What does that mean? The median is found by computing the mean of the two middle numbers.
The median could be halfway between your two middle.
Halfway, exactly. You take the two middle numbers, you add them and divide by 2. So when you have an even number of values like this, 50, I'll put them in order, make my life easy. 60, 62, 65, 70, 74, 76, 80. Is that even or odd? 1, 2, 3, 4, 5, 6, 7, 8. That's an even. If I take this number, it's not the median. Why? You have 3 to the left, and how many to the right? 4. If I take this is not the median. 4 to the left, 3 to the right. This one says take the average. The mean is the average of the two middle numbers. Take the average of these two numbers. 65 plus 70, divide them by 2, which is what? 67.5. That's my median. That's my x tilde. The red is horrible here, huh?
Yeah, it doesn't look bad from where I'm sitting.
Is okay? Can you see it from your angle? Okay. So we take the two middle ones, add them, and divide by 2. Notice how many values less than 67.5? 1, 2, 3, 4. How many values larger than 67.5? 1, 2, 3, 4. That's your median. Later in the course, you'll hear me mention something about these numbers. The median is called the 50 percentile. Why is it called the 50 percentile? Because 50% of the values to the left of that, 50% of the values to the right of that. Has a different name too, called quartiles. And the last topic between mean, median, we left one more, and that's what? The mode. So let's look at the mode. I'll use this marker. Mode. Definitions: the most frequent, or the value. Sometimes more than one value. Could be values that occurs with the greatest frequency. Translation: most frequent. The value or values that you will see with the most frequent. Again, you could have more than one value. You could have no values, no mode. So here are some numbers. 50, 60, 70, 80. What's the mode? No mode. There is not a single number that showed up more often than the rest of them. $50, $60, $50, $60, $80, $50. What's the mode? 50. Just the 50. 50 is the mode. Just the 50, not 50 and 60. 50 showed up what? 3 times. 60 only showed up twice. Only one mode. Going back to this, 50, 60, 50, 60, 80, 50, 60. The mode is what? Both of them, 50, comma, 60. So you have two modes. They both showed up here more often than the rest of them. So you could have one mode, no mode, 3 modes. Which one or ones showed up more often? Couple more topics or terminology here. You'll hear me use the word range a lot here. And the range is really the high value minus the low value. That's what the range is. So if you hear me mention the word range, I'm talking about the difference between the high value to the low value. My numbers are within how many points from each other? Again, assuming these are the scores of some example. Let's say we looked at the number of inches of snow we got yesterday. Ludlow says 10 inches. East Long Meadow 12 inches. Wilbraham 16 inches. I'm just throwing some numbers. Hadley is 13 inches. West Springfield 15 inches. Chicopee 12 inches. What is the range? The range is the difference between the high value and the low value. My highest number is 16. My lowest number is 10. That's 6. All my values within 6 inches from each other. That's what that means. So that's the word range. And what about the mid-range? The mid. You probably can figure what that means. The middle value of that number. What's the middle value of this number?
3.
Yep. So the mid-range is really the high value minus the low value divided by what? By 2. So in this case, it will be 16 minus the 10 divided by 2, which is 3 inches. Talking about snow here. 3 inches of snow. So you might hear the word mid-range versus the range. That's the difference between them. Oh. I should say plus. Because you're trying to find what that number is. Add them, which is what, 13? The mid-range of my values is 13, not a minus, I mean. The difference between them is 3. But the actual location is actually the plus. If you want to find what that number is, you add them, which is 13. The gap is 3 from the lowest to the highest. So if you're looking at your number, this is the lowest, which is 10. This is the highest, which is 16. We're saying that gap, the mid value is 3. 3 from this number is going to make that number what? 13. So if you're looking for that number, you add them and divide by 2. And that's what the mid-range is. The range is the high minus the low, which is the difference between this and that. The range is 6 values. But the mid-range, we take, add them, and divide by 2 to get that number. What's nice about these actually numbers, they're really easy to calculate. The one thing I didn't show you is we talked about calculating the mean. Now, so we just add all the values, divide by the number of values. Oh, that sounds good, but let me give you a different story. Let's say we did a study. We asked people, can you tell us how many siblings do you have? Here's the result. X is the number of siblings, and this is the frequency. 0 sibling. We have 10 people that have no siblings. 1 sibling. We have 22 people that have 1 sibling. 2 siblings. 26 people. 3 siblings. We got 18 people. 4 siblings. We got 12. And 5 siblings. We got 4. I'm going to stop here. I'm sure there's other people with 6, 7, 8. That's plenty. How would you calculate what the mean is? That means you get 10 values of zeros, 22 values of 1, 1, 1, 1, 1, 26 values of 2, 2, 2, 2. To find the mean, usually you add them and divide by the number of values, but not when you have a frequency distribution table. This is a frequency distribution table. But normally a frequency has a range of value. This actually has single values here. Frequency mean. How do you find the mean when you have frequency table? The way we find the mean, assume it's a sample, I use x bar. Oh, not tilde, that's a median. X bar is equal to the equation for that, the summation of f times x divided by the sum of f, which happens to be equal to n. When you add all the frequency, that's really what n is. So now I need to multiply 0 times 10. This is f times x. 0 times 10, 0. 1 times 22, 22. 2 times 26, is that 52? 3 times 18, is that 54, I think? 4 times 12, 48. 5 times 4, 20. I need to add them. 2, 4, 8, 16. 196? And this one, 0, 2, 8, 16, 20, 22. 3, 4, 7, 8, 9. Is that 92? So this one here is the sum of f times x. This one here is the sum of f. So what is my average? It's going to be 196 divided by 92. And what do we have? Have a calculator here. 196 divided by 92. 2.13 sibling. So the sample we tested has 2.13 sibling. So when you have frequency distribution table, you have to use that one. Okay. We ask people how many siblings. That's, straight for 0, 1, 2, 3, 4. Sometimes actually the numbers are into ranges. Let's say we have a different sample. We ask people, smokers only, how many cigarettes a day do you smoke? But instead of giving single values, we broke them into classes. These are smokers, so you can't have a 0. That means you smoke at least 1 cigarette. Let's say we have 1 through 5. This is the frequency. We have 8 people. Says I smoke between 1 and 5 cigarettes per day. 6 to what? Is it 10? Because the next number, what's the class width? What's 6 minus 1? 5. The next one should be what? 5 and 6? 11. The next class should be 5 more, which is what? 16. The next one should be 5 more, which is 21. Remember that class width? It's the difference between 2 consecutive lower limits. Now, if this one starts at 6, that means this one ends at 5. 5 more, that's 10, that's 15, that's 20, and that's 25. The rest of them were dead from smoking too much. So that's why nobody else after that. We got 16 people, we got 28 people, we got 18 people, and we got 9 people. And I want to calculate the mean. That's a frequency table. Frequency distribution. So to calculate the mean, still the same equations, the summation of f times x over the sum of f. I can get the sum of f, that's no big deal. Add the frequencies. Here's my calculator. 8 plus 16 plus 28 plus 18 plus 9. It says 79 people. But what about f times x? What is x? Do we even know what x is? No. So what are we going to use? For x, what are we going to use? We know we have 8 people. They smoke between 1 and 5 values. What would be a fair number to use for them? It's called the midpoint. For 1 and 5, the midpoint is 6. You add them and divide by 2. 1 plus 5, 6 divided by 2 is 3. 6 plus 10 is what? 16 divided by 2, which is what? Oh, that's 3. I wrote 6 here, right? 6 plus 10, which is what? 16 divided by 2, 8. That's 5 more. Guess what the next one is? 5 more. 5 more. 5 more. That's what I'm going to use for them. So now I need f times x. 3 times 8, 24. 16 times 8, 128. 13 times 28, 364. 18 times 18, 324. And 9 times 23, 207. And now I got to add them. When you add them, that's 1047. So my average here, 1047 divided by 79, which is 13.25 cigarettes per person. So the average person smokes about roughly 13 cigarettes per day. That's what that means. A little bit more than half a pack. So when you have frequency distribution table, calculating the mean is a little bit different. And the last twist maybe is, what about if they have different weights? What does that mean? Let's say I'm given a test, and they don't have to add up to 100%. We try to make them add up to 100. I can make the percentage any number. But let's say we have the final grade for the course is based as final grade. It's going to be based on the following. Test 1, final exam, homework assignment, and test 3. Test 2 I'm not going to count. I want test 1 to be worth 20% of the grade. I want final exam to be worth 40% of the grade. That's 60. I want the homework to be 15% of the grade. 75. Now I'm doing this right. This would be what? 25% of the grade. So I can put different percentage to them. And let's say test 1, you scored 100 on it. Good job. Homework, you got a 96 on it. Did all the homework assignment. Test 3, you got a 90. But the final exam, for some reason, you only got a 70 on it. What people will do, and I get tons of emails about this, I average my scores, and I don't get the same thing as you did. My average is higher than what you're telling me, because they don't count the percentage. So when you have a different percent, the average should be the value times the weight or the percent of it divided by the sum of the percent or the weight of each one. W for weight. So the average here will be what? 100 times 0.2, 20% is 0.2, plus 70 times 0.4, plus 96 times 0.15, plus 90 times what? 0.25. When you add all the percentage, the weights, 20, 40, 50, and 25, isn't that 100%? Divided by 1. Let's see what your average here. Your average is 84.9, which is a B for the course. Now, if you just took the scores and averaged them without looking at the percentage, if you just go 100 plus 70 plus 96 plus 90, you add them and you divide by 4, you got an 89. It should have been a B plus. No. The weight. So sometimes some of the values have more weight than others, so you have to include the percent or the weight of each one. So these are weighted means. That's why we use the letter W for that. You know where we use weighted means? Anyone? For students, think of a student. Let's say you signed up for 4 classes. And these are your grades. You had chemistry, 4 credits, and you got a chemistry. We'll give you a B. Depends who your teacher is. Now physics, 4 credits, and let's say a C here. Calculus, 4 credits, A, especially if you have burns. You know? And now we're going to take one more class, and that is English Comp 1. 3 credits, and you got a B. Each one of these have a different weight. The B is what? 3.0. The C is what? Your GPA, 2.0. The A is what? 4.0. And the B here is what? 3.0. So your GPA for this semester is going to be what? 4 times 3.0. Plus 4 times 2.0 plus 4 times 4.0 plus 3 times what? 3.0 divided by the number of credits that you taken, which is what? Is that 15 credits this semester? So let's see what your GPA for this semester. And divide that by 15, your GPA happens to be 3.0 on the money. Oh, 4 times 3, yep, 12, plus 8, plus 16, plus 9, yep, 3.000. You finish the semester with the B average. So there's a place where we use actually weighted score. I'll stop with this.